I will give now the floor to Ms. Birkbak. Mie is specialist in the innovation and concept department of Vestas, the pioneer wind turbine, European wind turbine manufacturers. She comes with a background in material science with PhD in nanoscience, investigating how we can learn from biological structures when designing novel materials. In her current position, she is focusing on how we can use advanced materials for the increased sustainability of wind turbines. So, Mie, the floor is yours.
Yeah, thank you so much. And really a pleasure to be here and also to speak immediately after Alex, who really gave us all a good insight in sort of the problem we are looking into and the drivers that will lead us towards this change in how we view materials going into wind turbines. And so today I'll take you a little bit on a tour on how we see this being unfolded, both in regards to how we can treat our legacy fleet, so blades that are already on the market and the blades we are producing right now, and also looking into the future. What can we do to make life easier for the next generations to come, and even just ourselves some years down the line. Right. So let me just start here. And actually, this sort of ties into the waste hierarchy pyramid we just saw before. Because what the very best thing we can do sustainability-wise is to produce structures that will last forever, or at least for a very long time. And this is the development that we have seen in the industry for the past many years. We are producing products that can last for several decades in very harsh and extreme conditions. This awards us with some products that are generally very, very sustainable and that provide us with sustainable energy in a way that cannot compete with other technologies. The flip side of this is, of course, that things that is meant to last for a long time is also very difficult to handle in a efficient way when it comes to end-of-life treatment. So I think being in a sustainable company, in a sustainable business, this sort of challenged us to find these solutions to a problem that actually arises from the sustainability itself. So with this sort of mindset we've seen, sustainability is essential to all of us in the business. It's a good question to ask, why is there not already sort of a mature value chain for blade recycling? And some of the answers to this is that it's difficult technological to reach it. The value of the raw materials is relatively low. And as we also heard before, it's unproblematic, it's safe to landfill this material. So the drivers have been in the past a little bit hard to find, but now that we have come so far, I think everyone wants to push this agenda and solve the problem. So here I've just brought you an image of a turbine that has been through a shredding process. And what is quite evident from this, that shredding is it's often the first step in many of the current technologies available for recycling as of today. But as you can see, it's not super uniform. And that's basically a technological challenge, and it's quite easy, maybe the easiest thing to visualize, and something we will need to bear in the back of our head when we are designing large-scale industrial ways of treating this material. But apart from this very sort of visual effect of having composites shredding to a material that is not super well defined, there are also additional challenges. One is basically volumes and materials. And even though we just heard that the volumes that we are going to recycling over the next year will be be large and also many doubled, we're actually only a small part of the amount of composites that is being scrapped. But we have some quite unique features in our industry. We have relatively few players on the market, and we understand our problems very well. This means that we can sort of be a player in specifying what kind of volumes can we expect, and analyzing this material flow to a degree that is probably not possible for other industries. So this understanding of material flows and also enabling end customers of recycled material to understand what is a sufficient and predictable volume of material they can expect to get, that is essential for recycling companies to understand. The next step is to understand the technologies, including these that were mentioned in the previous presentation. And what we are focusing on in a project I will just mention to you in a moment are basically these three technologies: mechanical shredding, pyrolysis, and cement co-processing. And these are all considered viable and relatively technological, well developed. So even though they're not fully there, we understand the potential. And digging a bit deeper into this will also lead us to understand the quality and the consistency and the amounts coming of material coming from these various recycle options. Finally, in order to actually succeed in getting a well-founded value chain for blade recycling, is to understand what is actually the sustainability impact of this. So that includes figuring out how can we transport and process the material in the optimal way. What cost can we affect? What climate effects can we expect? And what environmental perspectives are there related to these different technologies? And all of these analyses would sort of go together and allow us in the industry to mature not only the technology, but the entire value chain, securing that it's not only an option that blades are being handled in a sustainable way at end of life, but also that they're actually being handled. So the project that we are part of, together with other large OEMs, with also a number of recycling companies. Ørsted is represented, and then we have some academic partners called Decomblades. And Decomblades is essentially this consortium that is going together and say, okay, this is a challenge that is across the entire industry. Let's consider it as a challenge that we can really lift by adding the knowledge from the turbine producers to the knowledge that comes from the technical side, and then do the analysis from the beginning. So this integration of technical development and value chain, financial, economical development will hopefully lead us to understand these processes much better than we do today, and put us in the position to really respond to this landfill ban that everyone are expected to be an essential part of our future. So with this initiative, we hope to pave the way for a much more sustainable end of life for composites, specifically wind turbine blades, but in general for composites. But being a large turbine producers like us also gives us the unique opportunity to make life easier on the long term. And this can be done by developing and maturing products, technologies that can work as a centrally integrated part of the design of materials. And basically, the next question will be then, okay, how do we bring these technologies to life? And basically, it's threefold, just as we see from the how we can handle the existing value chain. It taps into the technological development. So first of all, we need a technology that makes this physically possible to recycle composite material in a way that is better than what we can do today. Then we need a sentiment financially. Basically, we need a viable business case to drive this and to engage various parts of the value chain. And then finally, this needs to be integrated across multiple sectors, hopefully, to enable these sort of large volumes of material to drive a secure and stable source of material, which is needed for recycled material really to excel and be our preferred solution for when we're producing new products. So with this is a challenge we are addressing with our project called CTEC. So CTEC aims to develop recycling technologies that will enable us to make a truly circular resin system. So contrary to what we've been talking about before, composites exist or consist of fibers, can be glass, can be carbon, but also essentially a resin that is holding everything together. And by addressing that part of the material, we can not only separate the fibers from the rest of the structure for entering into fiber recycling pathways, but by addressing the resin directly, we can tap into a chemical recycling process where we are extracting the value of that part and further treat that in a chemical process, a catalysis-based process, where we extract the raw materials going into resin. And these raw materials are, chemically speaking, exactly the same as virgin material. And that means that they can directly substitute other virgin material and enter into a truly circular resin. And old blades can become parts of new blades. Here on this, the small video, I'm sorry. Small video not running. You see basically two types of epoxy, and it's in this very mild condition. And you see our aconventional epoxy is just lying there, while our newly developed epoxy is crumpling, releasing the fibers, and eventually we can bring this all the way back to virgin-like material. This technology also comes with sort of this manifold challenge. There's a technological challenge. So basically, the essential part here is to keep up the value of recycled material. That means the fibers, we should not integrate these recycling properties into so harsh conditions that the fibers cannot be used in a meaningful way. But also importantly, we should aim to extract the value also of the resin. Combining that will give us a very high value of the recycled material. That still is come with the eyes really focused on how do we do this? What is the energy consumption? What is various environmental properties of material or chemistry put in this? And also, quite importantly, there must be a potential to doing this locally, so we don't need to transport waste all over the globe. But with the technology we have demonstrated and we are now currently scaling, this gives us a way of really start to close the loop. So using old material blades for new blades, and in this way we can transform what was before a waste problem into a source of raw materials and enable us to transform waste into a valuable product. So just in conclusion, I just wanted to say that the technological development is it's only one part of this, and it's of course really essential that we understand the how we can do the technical process in a way that will give us high quality end of life products, but or recyclates, but also to understand all the things around this. It includes the energy we use for these processes. It includes infrastructure, transport, volumes, and basically also the commercial incentive, meaning that we really need to heighten the value we get of recyclates. So with that, I will thank you for your attention and hope that we can have many more discussions on how we integrate the technological and the commercial side of this for a future where we see much more sustainable options for wind turbine blades, specifically, but composites in general. Thank you.
Thank you, Mie. I have to inform you, because obviously you have not heard during our morning session in Greek, that our General Secretary of Environment in the Ministry of Energy and Environment is a chemical engineer with a PhD in recycling of composite materials.
Oh,
So
I'm
I'm
really
sure,
happy to hear that.
yes. I'm sure that he will find very interesting your presentation, as well as the presentation of Jonas, who will follow now.